Number 1. A box experiences a normal force of 10 newtons, a force of gravity of 10 newtons, an applied force of the right of 7 newtons, and a friction force of 4 newtons. What is its net force? So the first thing that we need to do is, wait for it, draw the object. So we're going to draw the object first. Okay, a box. There you go. Step 1. Step 2, draw and label all the forces. So we're going to draw them on here, and we're going to write what they are. So it says a normal force of 10 newtons. Normal force is up. It's against gravity, so I draw an arrow up. Write Fn equals 10 newtons. Force of gravity of 10, so that's down. Newtons. Applied force to the right of 7. Now that should be a little bit smaller than these other ones, but not super small. And then a friction force of 4. Friction is always against motion. This is by far the smallest force, so I'm going to draw it the smallest. Now, by the way, newtons are the unit for force. Okay? So far, so good. So, we've done step 1, we drew the objects. We've done step 2, we drew and we labeled all the forces. Step 3, draw and label the acceleration / the net force. If we don't know what it is, we write A equals question mark. Now, this is where it gets kind of tricky. You're trying to draw in the motion direction / change direction. There's a lot of stuff trying to go on here. So, I'm trying to figure out which direction is the change happening in. Is the change happening up and down? Probably not. But it does says I'm applying a force to the right of 7, and friction is going to be opposite, but less. So that makes me think that the change is going to be happening to the right. So I'm going to draw an arrow to the right. And since I don't know what the acceleration is, I'm just going to write A equals question mark. All right, step 4, find the net force. There are 2 ways to find the net force, and they are both at the bottom of the paper. The first way to find net force is to do F net equals ma, Newton's second law. The second way is to do what we've been doing, which is combine all the net forces together. Everything up is positive, anything down you would subtract. So I look at this and I say, well, I don't know mass or acceleration, so F equals ma is not going to work. So I'm going to need to combine all the forces together. Okay? So first thing I want to do is add them all up. Okay, so here we go. Let's add them all up. F net equals here we go. 10 plus 7 plus 10 plus 4. 31. Done! Oh, come on now. Don't let me off the hook that easy. There we go. I did it wrong. Little tear. What did I do wrong, Dylan? Yeah, I can't add everything together. I can only do x's together and y's together. So let's do the x's together. F net equals forwards added together minus the backwards. So forward is 7 minus the backward, which is 4, gives me 3 newtons to the right. Okay, let's do the y now. 10 minus the other direction, 10, gives me 0. So what's the net force? 3 newtons to the right. Yep. Find the net force. Done. There we go. So now you kind of see what you're doing. You're combining all your things together. You figure out which is the right direction to do. And then you set up and you move things in that direction. You have to do x and y separately. And you're going to get one answer. One direction will be 0. The other direction will be something else. Or they might both be 0, in which case your net force is 0. And that's fine too. All right, let's look at number 2 now. So a box has an applied force to the right of 20 newtons and a force of gravity of 5, which result in a net force to the left of 15. What's the force of friction and the normal force acting on it? So same thing, except this time, instead of drawing, well, I guess it's a box. I can draw a box easy enough. So here we go. Here's my box. I'm going to go a little faster here with the drawing the forces. Okay, draw and label all the forces. So it says there's a force to the right of 20. A force of gravity down of 5. Force of gravity down of 5. And then result in a net force to the left of 15. Okay, so my motion change, my acceleration, my net force, my other stuff that I draw over here, it's backwards. There we go. That's much more helpful. All right, then it says, which is the force of friction? What is the normal force acting on it? So, what is the normal? What's the force of friction going to be? So, this is a little bit different. I had all of the forces, so I added them together to find the net force. Now I know the net force. I'm going to have to add the forces together to find what I'm missing. So F net equals all your forces added up. Positive things in the right direction, add. Things in the opposite direction, you subtract. Okay? In the x direction first. 15 is my net force. I'm going to make that my positive direction. That's the direction of the net force. Okay? So that's going to equal friction, which is in the same direction, minus the applied, which is in the opposite. Add 20 to both sides. Friction is 35. I'm going to do the same thing now with the y direction. The net force is 15 to the left, which means up and down it's 0. And that's normal minus gravity, which is 5. Add 5 to both sides. The normal is 5 newtons.